So, this is our hypothesis, and our hypothesis was, if the smaller amount of magnesium is used, then the less H2 is produced.
This diagram shows how we did this experiment. So first off, we have a burette filled with water, and that is placed into a beaker also filled with water to make sure the water doesn't come out. From there, we placed a tube that connected the burette to the test tube, and within that test tube was hydrochloric acid and the magnesium strip. We then used a timer to time how long the reaction took. Overall, this lab took 181 seconds to complete. We used a 0.02 gram strip of magnesium and placed it into 25 milliliters of hydrochloric acid. This hydrochloric acid had the molarity of 1 and had a temperature of 22.9. As the experiment went on, the initial volume of H2O in the burette was 43.8, and by the end of the experiment, there was 29.1. So after doing calculations, we got that 14.7 milliliters of hydrogen gas was created in this experiment.
So, our procedure was, number 1, we weighed the magnesium. Number 2, we put 50 milliliters of H2O in the burette. We placed the burette into the beaker to prevent the H2O from escaping. Number 4, we filled the test tube with 25 milliliters of HCl. And number 5, placed the magnesium strip into the HCl. And number 6, started the timer. Number 7, we stopped the timer, recorded how long it took for magnesium strip to dissolve, and finally we found the rate of production of H2.
Okay, so for the calculations, we got 14.7 ml of H2 gas, which we divided by the amount of time that it took, which was 181 seconds, and we ended up with 0.0812 ml of H2 gas per second. And since the weight of the magnesium was 0.02 grams, and we needed to find the amount of moles, we took the mass of the magnesium and divided it by the molar mass of magnesium, which was 24.31 grams. And so from 0.02 grams divided by 24.31 grams, we got 8.22 times 10 to the negative 4 power moles of magnesium. And to find moles per second, we took the amount of moles, 8.22 times 10 to the negative 4th power of moles of magnesium divided by the time, which was 181 seconds, and we got 4.54 times 10 to the negative 4th power. And since it's a 1-to-1 ratio, the final answer to find the amount of moles of H2 gas was 4.54 times 10 to the negative 4th power moles of H2 gas per second.
So for our conclusion, we found that the smaller amount of magnesium we use, the less H2 is produced.